A quadratic sequence is a sequence where the nth term is a quadratic. So the nth term is in the form an squared plus bn plus c. In the first example here, we're going to generate a quadratic sequence. So we've got the nth term, 2n squared plus n minus 5. For the first term, so for term 1, n is 1. So we substitute in n is 1 to find the first term. So we're going to have 2 times 1 squared plus 1 minus 5. So that's going to be 2 1s, which is 2, plus 1 minus 5. 2 plus 1 is 3. 3 minus 5 is negative 2. So the first term is negative 2. For term 2, the second term, it's going to be 2 times 2 squared, which is changing n into 2, plus 2 minus 5. So that's 2 squared is 4, so 2 4s are 8, plus 2 minus 5. 8 plus 2 is 10, 10 minus 5 is 5. So term 2 is 5. The third term is going to be 2 times 3 squared, plus 3 minus 5. 3 squared is 9, 2 9s are 18. 18 plus 3 minus 5, so 21 minus 5 is 16. So the third term is 16, and the fourth term is going to be 2 times 4 squared plus 4 minus 5. 4 squared is 16, 2 16s are 32, so 32 plus 4 minus 5, so 36 minus 5 is 31. So we have minus 2, 5, 16, 31. And they are the first 4 terms of the sequence. Okay, one for you to try. So generate the first 4 terms of this sequence. So we're going to have for the first term, n is 1. So it's going to be 1 squared plus 2 1s plus 5. The second term, n is 2. 2 squared plus 2 2s plus 5. For the third term, n is 3. 3 squared plus 2 3s plus 5. And for the fourth term, n is 4. So 4 squared plus 2 4s plus 5. So 1 plus 2 plus 5 is 8. 4 plus 4 plus 5 is 13. 9 plus 6 plus 5 is 20. And 16 plus 8 plus 5 is 16 plus 8 is 24, plus 5, 29. So the first 4 terms are 8, 13, 20, and 29. Okay, now we're going to look at finding the nth term. So finding the nth term of quadratic sequences. I'm going to show you why the method I'm using works. So I'm going to show you the proof of the method before we start using it. You don't have to remember this proof. You don't have to remember how we got there. You just need to be able to apply it. But let's have a look. So we've got an squared plus bn plus c, and this can represent any quadratic sequence. So that represents any quadratic sequence, and I'm going to generate the first 3 terms. So for the first term, n is 1. So if n is 1, we've got 1a, 1b, and 1c. So if n is 1, we've got a plus b plus c. If n is 2, so the second term, 2 squared is 4, so we've got 4a 2 times b is 2b. So we've got 2b and we've got c. And for the third term, n is 3. So 3 squared is 9. 9 times a is 9a. 3 times b is 3b. And we've got a c. So these are the first 3 terms of any quadratic sequence. And now let's look at the difference. So the difference between the first and the second term. What is the difference between the first and the second term? 4a take away 1a is 3a. 2b take away 1b is a b. And c take away c is nothing. So the difference between the first 2 terms is 3a plus b. How about the difference between the second and third term? So 4a to 9a is 5a. And 2b plus a b makes 3b. And c take away c is nothing. So the difference between term 2 and 3 is 5a plus b. How about the difference, the second difference? How about this difference down here? So the difference between 3a plus b and 5a plus b, the difference there is 2a. And so what we can say, for any quadratic nth term, for any quadratic sequence, the first term is going to be a plus b plus c. The difference between the first term and the second term is 3a plus b. And the second difference is 2a. And this will be true for any quadratic sequence. So let's have a look at a quadratic sequence. So here we've got the first 5 terms of a sequence. Let's work out the first difference. So from 6 to 15 is 9. From 15 to 28 is 13. And from 28 to 45 is 17, and so on. The second difference, the difference between 9 and 13 is 4, and 4 again. So let's have a look at what we had. So we can say the first term is a plus b plus c. So this first term here, 6, is a plus b plus c. The difference between the first and second term is 3a plus b. And the second difference is 2a. So we can form equations here. So we can say 2a is equal to 4. So we're going to find what a is, what b is, and what c is, and we'll find the nth term. So 2a is 4. If 2a is equal to 4, what is a? Well, divide both sides by 2, and we get a is equal to 2. So we've got 2n squared. Let's find out what b is using the next equation. So 3a plus b is equal to 9, but we know a is 2. So if a is 2, 3 times 2 plus b is equal to 9. So 6 plus b is equal to 9. So b is 3. So that means we've got 2n squared plus 3n. And now let's find out what c is. We know a plus b plus c must be equal to 6. So a plus b plus c is 6. So 2 plus 3 plus c is equal to 6. 5 plus c is 6. So c is 1. So we know what a is, we know what b is, and we know what c is. So we've got 2n squared plus 3n plus 1. And that is the nth term of our sequence. So if we substituted 1 in here, we would get 6. If we substituted 2 in, we'd get 15. If we put 3 in, we'd get 28, and so on. Okay, one for you to try here. So if you're ready to give it a go, do so. Otherwise, just keep watching. The difference between 5 and 14 is 9. 14 to 25 is 11. 25 to 28 is 13, and so on. The second difference is 2. So we know for any quadratic sequence, the second difference is equal to 2a. The difference between the first two terms is 3a plus b, and the first term is a plus b plus c. So let's solve these equations, or let's write them as equations first. 2a equals 2. Divide both sides by 2. A must be 1. 3a plus b equals 9. And we know a is 1. So 3 1s plus b is equal to 9. 3 plus b is 9. B must be 6. And a plus b plus c is equal to 5. The first term is a plus b plus c. A is 1. B is 6. So we've got 7 plus c equals 5. Take 7 away from both sides. So c is -2. So remember, it's the form an squared plus bn plus c. So we've got 1n squared, which we can just write as n squared, plus 6n minus 2. So this is our nth term. So if we substituted 1 in, we'd get 5. If we substitute 2 in, we'd get 14, and so on. And another example. So we're going to do the same thing. We've got negatives involved, but the process is going to be the same. So the first difference, so we've got 2, and then -2, then -6, then -10. And then the second difference, so it's going down 4 every time. The second difference is -4. So from 6 to 8 is 2, from 8 to 6 is -2, from 6 to 0 is -6, and from 0 to -10 is -10. And then the second difference, from 2 to -2 is -4, and so on. So they're all -4. The same as last time. So we've got 2a. The second difference is always 2a for any nth term, any quadratic nth term. The difference between the first two terms is 3a plus b for any quadratic nth term. And the first term is a plus b plus c. So this is what you'll have to remember in order to answer these questions, or you could remember how to work it out and find it yourself every time. So let's answer it. So 2a is equal to -4. What's a? We'll half both sides. A is -2. 3a plus b is equal to 2. A is -2, a is -2. So 3 -2s, 3 -2s is -6. -6 plus b is 2, plus 6 to both sides. B must be 8. And a plus b plus c equals 6. So we've got -2 plus 8 plus c equals 6. -2 plus 8 is 6. So 6 plus c equals 6. What's that make c? So take 6 away from both sides, and c is nothing. C is 0. So what is the nth term? We've got -2 n squareds. We've got 8 n's and no c term. So we've got -2n squared plus 8n. So if we substituted 1 in, we'd get 6. 2 in, we'd get 8, 3 in, we'd get 6, 4 in, we'd get 0, and so on. Okay, one for you to try. So give this one a go. So let's calculate the differences. So it goes up by 5, up by 11, up by 17, and so on. And the second difference is 6. And we know for any quadratic nth term, the second difference is equal to 2a. The difference between the first two terms is 3a plus b, and the first term is a plus b plus c. So let's use this to work out our nth term. So 2a is equal to 6. Divide both sides by 2, and we find a is 3. 3a's plus a b equals 5. A is 3. We've already worked that out. So 3 3's plus b is 5. 9 plus b is 5. Take away 9 from both sides. So b is negative 4. And a plus b plus c is equal to the first term, which is negative 8. And we've got 3 plus minus 4. I'll just write as minus 4 plus c equals negative 8. 3 minus 4 is negative 1. So negative 1 plus c equals negative 8 plus 1 to both sides. So c must be negative 7. So we've got a is 3, 3n squared, b is negative 4 minus 4n, c is negative 7 minus 7. So it's 3n squared minus 4n minus 7. And another example. So same process, work out the differences. Negative 3 to 6 is 9. 6 to 20 is 14. 20 to 39 is 19. And the second difference is 5. And so the bit we remember, the second difference is 2a. The difference between the first two terms is 3a plus b. And the first term is a plus b plus c. So 2a equals 5. What's a? So half each side. So either 5 over 2 or 2.5, whichever one's easier. I'll write 2.5. It might be easier in the calculations. 3a plus b equals 9. So 3 lots of 2.5 plus b equals 9. 3 2.5s make 7.5. And then take 7.5 away from both sides. So b is 1.5. And a plus b plus c is negative 3. A is 2.5. B is 1.5. 2.5 and 1.5 make 4. So 4 plus c is negative 3. Take 4 away from both sides. C is negative 7. So we have 2.5 2.5n squareds plus 1.5n minus 7. And one for you to try. So give it a go. First difference. So we've got 5, then 8, then 11. And the second difference is 3. So we know the second difference is always equal to 2a. The difference between the first two terms is always 3a plus b. And the first term is always a plus b plus c. So 2a is equal to 3. So half both sides. We can say a is 1.5. 3a plus b is equal to 5. A is 1.5, so 3 1.5s plus b equals 5. 3 1.5s make 4.5. So 4.5 plus b equals 5. So b must be half, a 0.5. And then a plus b plus c is negative 3. So 1.5 plus 0.5 plus c is negative 3. That makes 2 plus c negative 3. Take 2 away from both sides. So c is negative 5. So it is 1.5n squared plus 0.5n minus 5. And to finish up 2 questions, give these a go. Question 1 is asking for the first 5 terms of the sequence 2n squared minus 10. So the first term is when n is 1. 2 times 1 squared minus 10 is 2 minus 10, which is negative 8. 2 times 2 squared minus 10. 2 squared is 4. 2 4s are 8. 8 take away 10 is negative 2. The third term is when n is 3. 3 squared is 9. 2 9s are 18. 18 take away 10 is 8. The fourth term is when n is 4. So 4 squared is 16. 2 16s are 32. 32 take away 10 is 22. And the fifth term is when n is 5. 5 squared is 25. 2 25s are 50. 50 take away 10 is 40. So they are the first 5 terms. Question 2, find the nth term. So we're going to write down the differences first. So it's 1, then 6, then 11, then 16. The second difference is 5. And we have remembered, so for a sequence, an squared plus bn plus c. The second difference is always 2a, is always worth 2a. The difference between the first 2 terms is always worth 3a plus b. And the first term is always a plus b plus c. So let's use this to work out a. So 2a is equal to 5. Half both sides. A is 5 over 2, or 2.5. 3a plus b is equal to 1. So we've got 3 2.5s plus b equals 1. 3 2.5s are 7.5. So 7.5 plus b is 1. Take 7.5 away from both sides. So b is minus 6.5. And a plus b plus c is 2. A plus b plus c is equal to 2. So 2.5 minus 6.5 plus c is 2. 2.5 minus 6.5 is negative 4. So negative 4 plus c is 2. Plus 4 to both sides. C is 6. So we have, so remember it was an squared plus bn plus c. So 2.5n squared minus 6.5n plus 6.